Welcome back to the 8-2.3 page. We started the notes off with the first video with an investigation using the graphing calculator, and in this video we are going to take a look at what happens when we have a zero exponent. So it starts here and says, to understand why a calculator gives a value of 1 for 2 to the 0, study the two methods used to simplify 2 to the 4th over 2 to the 4th. So in this first method, they're telling us that using the quotient of powers, if you have powers with the same bases and you are dividing them, that all you have to do to find your answer is subtract your exponents. So we keep the base, the 2 stays the same, and then 4 minus 4 is written here. Now when you do 4 minus 4, that simplifies to a 0. So they're saying that in method 1, 2 to the 4th power divided by 2 to the 4th power is equal to 2 to the 0 power. Okay, now we're going to examine method 2. So they're using the definition of powers and saying, okay, if we have 2 to the 4th, that means we have 4 factors of 2, so 1, 2, 3, 4, and then same idea on the bottom. Now, we know that if you have something on the top of a fraction and on the bottom, they cancel out. So you see it, cancel, cancel, the first set cancel, and you've got 1, the second set cancel, you've got 1, third set cancel, you've got 1, fourth set cancel, you've got 1. So 1, you have all of these 1s. What's going to happen is you end up with 1 over 1, which is simply 1. So in method 2, they're saying that 2 to the 4th power over 2 to the 4th power equals 1. But wait a second. Aren't you thinking to yourself, well, didn't in the first method we decide that 2 to the 0 is what the answer is? So here's what's going to happen. It says, since 2 to the 4th over 2 to the 4th cannot have two different values, we can conclude that 2 to the 0 power is equal to 1. All right, from there, what we're going to conclude here is that for a zero exponent, when you have any non-zero number raised to the power, or raised to the 0 power, our answer is going to be 1. And we say non-zero number because in our investigation, we found out that when we did 0 to the 0 power, we got an error. So we don't want that. So it has to be some number that isn't 0. And if it's raised to the 0 power, then it's going to be 1. So to kind of continue these notes here, just want to make sure that I've got the right thing. So for any non-zero number A, all this is saying is if you were to take A and raise it to the 0 power, you're going to end up with the number 1. So taking a look at an example, if we had the number, let's say we had something crazy. Let's say we had negative 0.25, and we're going to raise that to the 0. Well, I'll tell you, regardless of what we put in these parentheses, any number we put in there is just going to result in 1 if it's raised to that 0 exponent. So this is kind of fun here. So instead of saying like we have a negative 0.25, we have this. We have 3x to the 5th over y, and all divided by 8x y to the 7th, and this is a whole negative number. In previous examples, we took the time to like simplify. We have x's on top, x's on bottom, y's on top, y's on bottom. But I'll tell you, no simplifying is necessary, because when you take this whole thing raised to 1, it's like taking just a single number and raising it to 1, or raising it to 0. I misspoke. So what's going to happen is as soon as you raise anything to the 0 power, it's just equal to 1. Now in this next example, it's a little bit more tricky for the fact that we're not taking this whole thing and raising it to the 0. We're just raising the s to the 0. So what this does is it just takes this, and that part is equal to 1. So you've got t to the 3rd power times 1 over t. So basically, this is kind of just canceling out. It's disappearing because t to the 3rd times 1 is just t to the 3rd. So with this, what we can do is we can think about, okay, well, if we've got 3 t's on top and 1 t on bottom, we're going to have some canceling taking place. So you can kind of think to yourself, it's t times t times t, all divided by t. We'll get 1 t to cancel on the bottom. There's nothing left there. And then one of the t's are going to cancel on top, leaving us with just 2 t's. So you don't really have to show this part. Oh no, what happened? My OneNote collapsed on me. Come on, OneNote, come back. That was strange. I have no idea what happened, but I'm going to get rid of that because that was just my thinking. So this is going to be a t squared because we had the t on the bottom and the t on the top cancel. 3 minus 1 is going to give us 2. So what this comes out to be, our answer, oh, that reappeared. That's strange too, equals... we just have the 2t on top, like t to t squared. There's our answer, t squared. Okay, beautiful. All right, now we're going to take a look at these problems here. So we've got a bunch of stuff, even scary stuff with negative exponents. But I don't want that to scare us off because we're just taking this whole thing and raising it to the 0 power. So I'm hoping that you're seeing the pattern here. Anytime you take something and raise it to the 0 power, it's just going to be 1. So this is equal to 1. Same idea here. 4c to the negative 2 times d all over b to the negative 2, c to the third, d to the negative 1. None of this matters because we're taking this whole thing and raising it to the 0 power. So it's equal to 1. Oh, crazy story. We've got the same thing going on in the next one. Negative 2x to the 4th times y, all divided by 4y squared. None of this matters on the inside because it's all raised to the 0 power, so our answer is 1. Same idea for the last one. This whole thing on the inside of the parentheses is raised to the 0 power. We're going to get an answer of 1. So anytime you raise something to the 0 power, you end up with 1. In this case, in example 1b, they only raised the s to the 0 power, so that's the only thing that we could turn into a 1. That's why we were left over with the t's and we had to do some simplifying. But remember, always, when you raise something to the 0 power, your answer is going to be 1.